change of order of integration. Generally, on changing the order of integration, the limits of integration is to be changed. To find the new limits, we can draw the rough sketch of the region of integration. Some of the problems connected with the double integrals, which seem to be complicated, it can be made easy to handle by a technique of change in the order of integration. Let us get into the details. The double integral with the variable limits for y and constant limits for x is this integral. To evaluate the integral, we integrate first with respect to y and then with respect to x. Sometimes this may be difficult to evaluate it, but change in the order of integration will change the limits of y from c to d, where c and d are constants, and the limits of x from g1y to h1y. It is the double integral, and hence the evaluation may be easy. To evaluate this integral, we integrate first with respect to x and then with respect to y. This process of changing a given double integral into an equivalent double integral with the order of integration changed is called change of order of integration. For doing this, we need to identify the region of integration from the limits of the given double integral. Sometimes this region may split into two subregions when we change the order of integration, and the given double integral will be sum of two double integrals. So for this, we can take a problem. Evaluate integral 0 to infinity integral x to infinity e power minus y by y dy dx by changing the order of integration. Inner integral is with respect to y. One of the limits in terms of x, so that these limits belongs to y, and x limits are constants. In the change of order of integration, you need to fix y, and you can draw the rough sketch of the region. You will take a horizontal strip on the region. For this, let the double integral be I. The region of integration is bounded by the lines y is equals to x, y is equals to infinity, x equals to 0, x is equals to infinity. The region is unbounded here. In the original integral, integration is first with respect to y and then with respect to x. This is a basic observation. But our application is change of order of integration. After changing the order of integration, first we need to integrate with respect to x and then with respect to y. That is very important postulate here. To find the limits of x, take a horizontal strip which is parallel to x axis. Here the point P on the line x is equals to 0 and another point Q lies on the line x is equals to y. That is most important thing. When we need to fix y, we can draw a horizontal strip on the region. This is x is equal to 0 is lower curve, x is equals to y is upper curve, so that the limits of x are x is equals to 0 to x is equals to y. The limits of y are from y is equals to 0 to y is equals to infinity. So this entire region can be covered from y is equals to 0, which is the starting point, and ending is y is equals to infinity, so that the limits of y became y is equals to 0 to y is equals to infinity. That is another important observation. Therefore, by changing the order of integration, we have the new limits integral 0 to infinity, integral 0 to y. First integrate with respect to x and then with respect to y. While making integration with respect to x, y can be treated as a constant, so that integral 1 dx becomes x. Evaluate the limits between 0 and y. We have y minus 0 becomes only y. Here y cancelled out. We have only e power minus y. Integration to e power minus y with respect to y becomes e power minus y by minus 1. Consider the limits between 0 and infinity. Negative 1 times. Wherever you have y replaced with infinity for upper result, y can be replaced with 0 for lower limit. E power minus infinity minus e power 0. E power minus infinity is 0. E power 0 is 1. Negative 1 into negative 1 is positive 1. So this is the result of double integral over the region by the technique of change of order of integration.